Welcome to the Atoms and Periodic Table video lesson. We're going to begin by talking about the subatomic particles. We have protons, which are located in the nucleus in the center of the atom, with electrical charge of +1 and a mass of very close to 1 atomic mass unit, just over. And neutrons are also located in the nucleus. These are neutral in charge, that's where the name neutron came from, and they have similar mass to protons. And then finally, the electrons are located outside of the nucleus. They're sort of orbiting around it in random patterns, and they have a charge of -1 and a much smaller mass than either a proton or a neutron. They're much, much lighter than those particles. The atomic number is located above the element on the periodic table. So if you look above the symbol there, you'll see an integer value. And this is like our identifier for each element. So sodium has the number 11, meaning that sodium always has 11 protons. And if we look at carbon, carbon's number 6 on the periodic table, indicating that carbon always has 6 protons. Any more or any less protons would represent a different element. When you see that term atom means electrically neutral. In other words, atoms have equal numbers of protons and electrons. So that number, the integer value above the symbol on the periodic table, the atomic number, indicates not only the protons, but it also indicates the electrons for an atom. So aluminum, for example, has 13 protons. It also has 13 electrons. And the total charge of an atom of aluminum is 0. The mass number is the sum of the protons and the neutrons. So in other words, it's the total number of particles in the nucleus. And the mass number is not located anywhere on the periodic table. So just be aware of that. Remember, the mass number is not on the periodic table. So if we look at the atoms of these elements, we have a lithium right here. Lithium has 3 protons, shown in red here. Then we have some neutrons, and we have 3 electrons. And then over here we have carbon, 6 protons, some neutrons, and we also have 6 electrons. So I'd like you to pause the video now and complete questions 1 and 2, but wait on question 2C. We'll deal with question 2C shortly. So let's use some of this knowledge. We have an example here. It asks about an atom of zinc with mass number of 65. How many protons are in the zinc atom? Well, we have to go to our trusty periodic table. Zinc is sort of 2/3 over to the right side of the periodic table with atomic number 30. And so that means that zinc has 30 protons. And then we're asked how many neutrons are in this zinc atom. Well, the zinc atom has 30 protons and a mass number of 65. 65 is the sum of the protons and the neutrons. Therefore, we must have 35 neutrons in this atom to sum up to that total of 65. And then finally, what is the mass number of a zinc atom that has 37 neutrons? Well, zinc always has 30 protons, and if we have 37 neutrons, 30 plus 37 gives us 67 as our new mass number. Isotopes are different forms of the same element. They have the same number of protons but differing numbers of neutrons. In other words, they have the same atomic number but different mass number. And the isotopes have very similar chemical and physical properties. They're virtually identical to each other. But one important way that they differ is that the isotopes with more neutrons or greater mass number will have a higher mass or a higher density associated with them. The more neutrons, the heavier our isotope. And so this is our symbol right here. And so right down below to the left we have our atomic number, our number of protons. Our mass number is to the upper left, and then we have the symbol for our element right here. I'd like you to now pause the video and complete questions 3 through 5 in the activity, and also now would be a good time to go back and finish question 2C. Now that we've talked a bit about atoms and isotopes, we should talk about the periodic table. So the periodic table is broken down into rows and columns. The rows are referred to as periods, and the columns are referred to as groups. And we'll actually be talking a lot about groups. The elements within a group have similar behaviors to each other, similar properties, and so it's going to be important to discuss those. So we'll be talking about groups quite frequently. This version of the periodic table shows which elements are metals, which are nonmetals, and which are metalloids. So interestingly, we can see that the vast majority of elements are going to be metals. We have this small band shown in green right here of metalloids, which are sort of between metals and nonmetals in terms of their properties. And then the upper right, we have a whole bunch of nonmetals shown in yellow, and hydrogen's hiding over here. So hydrogen's actually also a nonmetal, despite its location on the periodic table. So how do these different types of elements vary in terms of their properties? Well, the metals are shiny and ductile, and they're good conductors of heat and electricity. So if you think about a metal, it has all the properties you associate with a metal. It conducts electricity, it conducts heat, and it's shiny like a metal. And the ductility refers to the fact that we can change its shape without it shattering. So metals tend to dent rather than shattering. The nonmetals actually have the exact opposite properties. The nonmetals tend to be poor conductors of heat and electricity. They're often brittle, so the ones that are solid are usually going to be brittle. They're going to shatter rather than bend. And then the metalloids are kind of in between in terms of their properties. They're not particularly good conductors of heat or electricity, so they're used as semiconductors or sometimes as insulators. So I'd like you to now pause the video and complete question number 6. Let's talk about atomic mass. So you might be wondering what that decimal value beneath the symbol for the element is on the periodic table. This is what's known as the atomic mass, and it's the average mass of an atom of an element, considering all its isotopes and their relative abundances. So for example, the number below chlorine is 35.45. Chlorine in nature is made of 2 different isotopes. We have about 3/4 chlorine with mass number 35, and about 1/4 chlorine with mass number 37. And so if we average these together, these masses together, and we consider their abundances, their ratio, we end up with an average mass of 35.45. So let's talk about how to do this type of calculation. We take the mass for our chlorine with mass number 35, and our mass is 34.97 AMUs for this type of atom. And we multiply that by our percent abundance over 100. So 75.76 divided by 100 gives us a value of 26.49 AMUs. And then over here we do the same thing for chlorine 37. Our mass for the chlorine 37 is actually 36.97 AMUs. We multiply that by our percent abundance divided by 100. We end up with 8.962 AMUs. And so now we're going to sum these together. So we sum this value, and that gives us our weighted average mass, or our atomic mass for the chlorine, 35.45. Alright, so congratulations, you've made it to the end of this thing. Go ahead and complete question number 7, and then I suggest you go participate in the discussion.